Now, next thing we have to complete in the biosphere, that is lithosphere. Lithosphere means the study of the soil or below the surface of earth. What is present, that is the lithosphere structure or earth structure that we have to start. So if you look at the earth, and if I take a slice, suppose you have a round cake, and on that cake you take a slice like this. So this is the same kind of image here. This is our whole earth, and I am taking a slice of this earth. So this zone is the very center zone of our earth, and this is where we live, the outer layer. So in this particular slice, you can see that this is the ocean present, and this is the continent zone, or this is the mountain presence. So the very upper layer of where we live or of the earth structure, that is called as crust. So that crust height ranges from 0 to 100 kilometer, that you can see. After the 100 kilometer, the next layer which you can find out when you go deep down to the earth surface, that is called as the mantle. The mantle depth is up to 2900 kilometer, near to 2900 kilometer. That is called as mantle, MANTLE. Then coming to the very inner layer, that is called as the core. So this core is up to the very center of the earth, which is near to 76,400 kilometer, you can see, or very accurately, that is 6,378 kilometer. And this layer is called as the core. So we have three different layers on the structure of the earth. First is called crust, second is called mantle, then we call the third layer, that is core. Now, this crust is also divided in two different layers. One is called as continental crust, through which continents are formed, and another one is called as oceanic crust, through which oceans are formed. So that is very obvious. The thickness of the oceanic crust would be very less as compared to the continental crust. And the reason behind that, because continental crust is having land portion, or that is having high height. It is carrying the mountains. So the height of the continental crust would be very high, but the oceanic crust would be very thin as compared to the continental crust. Now, if you look at the density of the crust is somewhere around near to 2.7 gram per meter cube. And this is lowest among all the layers. So that is very obvious in the earth, because gravitation is very high when you go downside on the earth. So in the near to the core zone or near to the center of the earth, you can say that their density would be very high. And on the surface of the earth, the density would be very low. So it is very obvious that when you move from the surface to the inner side of the earth, the density continuously increases with depth. Here you can see. So density of the crust is 2.7 gram per meter cube. And coming to the mantle portion is having density of 2.9 to 5.7 gram per meter cube. And coming to the core portion is having 9 to 13 gram per meter cube of, you can say, density. So density is increasing when you are going downside on the earth surface. Now, another important information about the continental crust and oceanic crust is that the continental crust is mainly made up of the two metals, that is silica and aluminium. So that's why the continental crust nature is called as sial, because it is mainly made up of the silica and second aluminium. While if you look at the oceanic crust is mainly made up of the silica and magnesium. So the nature of the oceanic crust is sima nature, because it is made up of the silica and magnesium. So sima nature, you can say. If you look at the mantle is mainly made from iron and magnesium. So iron and magnesium, iron famic, it is called as famic, Fe for iron and mic for magnesium. So here mantle is mainly made from the firstly iron and secondly magnesium. The mantle density we have already talked, that is 2.9 to 5.7 gram per meter cube. Again, if you look at the upper mantle, the density would be low, that is up to the 2.9. When you go down and down, go to the lower mantle side, it will have very high density up to the 5.7 gram per meter cube. So that is divided in two types, upper mantle and, or two layers, you can say, upper mantle and lower mantle. Then coming to the core is the also same. It is having two types, that is the outer core, inner core. Outer core is having density of 9 to 12 gram per meter cube. Inner core is solid, totally solid. And this outer core is totally liquid. So this inner core is having more density. That's why it is solid in nature on that high temperature as well, to 12 to 13 gram per meter cube. And because the core is mainly made up of the two metals, that is the nickel and iron. So that's why the nature of the core is called as Nephe nature. So this is the structure and composition of Earth. Three main layers: crust, mantle, core. All are divided into more types. Crust is divided in continental crust and oceanic crust. Mantle is divided in upper mantle, lower mantle. Core is divided in outer core and inner core. Then another phenomena or another term comes here, that is the asthenosphere. Multiple times in the literature also you can see this word is used, that is asthenosphere. So asthenosphere is what? Asthenosphere is a layer that is just below the lithosphere and in the range of 80 to 200 kilometers. Just below the lithosphere means up to the crust part, you can say. Crust is having up to the 100 kilometers. So lithosphere is basically that crust part and very little portion of mantle, you can say, if it is oceanic crust, not continental crust, because thickness is very low there. So that mixing part is called as first lithosphere. And just below the lithosphere, that range which is in the range of 80 to 200 kilometers, this particular red zone you can see. This is called as asthenosphere, which is made up of the lower crust, some portion of the lower crust you can see here, and the some portion of the upper mantle. So that mixed layer, which is made up of the lower crust and upper mantle in the depth of 80 to 200 kilometers, that is called as asthenosphere. Now, this is overall idea about the structure and composition of Earth. Now we have to discuss in very detail about these different layers. First, we will start with the crust, then mantle, then core. One by one, we will discuss the details about all these layers of Earth. Now, coming to the crust portion. So, if you look at the crust thickness is very, very low on the Earth, all layers. It is, you can see, only having 0 to 100 kilometer of range. While the depth of mantle is 2900 kilometer, the depth of core is 6400 kilometer. So you can see how small amount of the earth layers is in the portion of crust. So it is only making of 0.5 to 1% of mass as well as 0.5 to 1% of volume of earth. You can say less than 1 and less than 1 in both the contribution of the crust in mass and volume of the total earth. Now it is divided in two types or two parts, that is the continental crust and oceanic crust. Continental crust is granitic in nature. This is important. The continental crust nature is granitic in nature because the granite type of rocks mainly you can find out in the continental crust. We will see in very detail in the chapter of rocks and soil as well. But remember that continental crust is called as granitic in nature because granite type of rocks you can mainly find out here. And it is having the nature of sial because silica and aluminum you can find out abundantly there or mainly there. And the old crust, it is a kind of old crust and it is thicker in nature. I have already told you because it is making the continents, the rocks, the mountains. So it is thicker in nature, having the range of 0 to 70 kilometer. While the oceanic crust is basaltic in nature. So basaltic type of rocks because made or you can find out in the oceans, below the oceans. So that's why it is basaltic in nature. Then the main two elements you can find out here, that is the silica and magnesium. It is called as young crust because it is found or it is made lately as compared to the continental crust, and it is having very thin boundary. That is very obvious because the ocean is in the deep or it is covered fully with the water. It is not having that much thickness. So that's why the range is only about 0 to 10 kilometers. Now, if you look at the all different elements or different metals, you can say, so what is the composition of the earth crust? If you look at the composition of earth crust, the majority of the element, the highest amount of element that you can find out in the earth crust as a whole, that is oxygen. That is very unique feature of the crust, you can say, and very strange as well. You can question as well, oxygen is a gas. So in the atmosphere also, we don't have oxygen that much amount. It is only about 21%. Remaining the 71%, 78% we have as the nitrogen, and more than 70% you can say. So why in the earth crust we have highest amount of metal, that is oxygen? Why not nitrogen? So because oxygen is constituent of all the rocks or the different minerals, you can say. Rocks are mainly made up of the minerals. Minerals are mainly made up of the elements. So all the elements like iron, aluminium, silica, these all are reactive, very, very reactive with the oxygen. So because when they are forming elements, they have reacted with the oxygen. So if you look at the rock, you can find out SiO2, you can find out Al2O3, you can find out FeO, you can find out Fe2O3. So in all the minerals, these are not in the pure form. These all are in the form of oxides. And you can see that in the every element, there is a huge amount of oxygen is attached. So that's why in the composition of the earth crust, because of these oxygen present with the metals, the oxygen concentration is very high. And in the earth crust, about 47% of the weight is made up only with the help of oxygen. So you can imagine how much amount of oxygen is trapped below the earth surface in the earth crust. The second most highest element amount you can find out is the silica, that is about 28%, aluminium 8.1%. Then we have fourth number of iron 5%, calcium 3.6%, sodium 2.8%, potassium 2.6%, magnesium 2.1%. You have to remember the sequence as well as you have to remember this percentage value as well. Both are important. You can remember like this: OCl, FeCa, Napoma. So oxygen, silica, aluminium, FeCa, iron, calcium. Napoma is sodium, potassium, and magnesium. So that kind of code you can create by your own as well. Also, because I have already told you that if you create your own codes, that would be more easy to remember. If you remember other people's code, then after some time or at some point, you will definitely forget that code. If you create your own code, you are never going to forget it. So always follow that rule. If suppose you don't want to create, you can remember this as well. But I will suggest you to create your own code and then remember it. Multiple times questions asked already found the sequence of the elements in the examination. Arrange the elements in the sequence of the abundance you can find out in the earth crust. So that kind of sequence you have to arrange or you have to find out in the options at least. So this sequence is only true for the earth crust, not for the whole earth. If you look at the composition of whole earth, the whole earth composition is like this. This is like POC, manganese, Cal. So POC, manganese, Cal means the highest amount of element you can find out in the whole earth, including core, mantle, crust. Highest is the iron, then oxygen, then silica, then magnesium, then nickel, then sulfur, then calcium, and at last aluminium. So this is the right sequence for the whole earth, including crust, mantle, and core. Another important thing that you have to remember here is the earth geothermal gradient. Earth geothermal gradient, like we have seen in the phenomena of atmosphere, there is a lapse rate. If you go high in the atmosphere, you can find out there is a decrease in temperature of 6.5 degrees Celsius per kilometer. But you start digging out and you go inside of the earth surface towards the center of the earth, so there would be constant temperature increase because of the presence of magma and all things below the earth surface. So that rate of increase of temperature below the earth surface is called as geothermal gradient. That is increase in temperature with increasing depth of the earth. And that rate of geogradient is 25 to 30 degrees Celsius per kilometer. This question was last semester's question. In the 2021 paper, you can find out this question was asked. Here I have provided the value in per kilometer. And there they have asked for per 100 meter if I am not wrong. So the answer here would be 2.5 to 3 degrees Celsius. Increase in temperature by going down per 100 meter of earth. So this value is important. Remember this earth geothermal gradient, that is 25 to 30 degrees Celsius per kilometer or 2.5 or 3 degrees Celsius per 100 meter. So basically, you have to divide just 10 because this is for per kilometer, this is for per 100 meter. So this is all thing about the Earth crust.